All right. Some of you are saying, why do we have triangles in physics class? This isn't geometry. Some of you are saying, we haven't learned this in geometry yet. So for some of you, this is a review. For some of you, this is a new lesson. Okay? So if you're a review person, wonderful, pay attention. If you're a new lesson person, pay very close attention. All right? So right here, we have a right triangle, right?
Wrong.
Oh, I got ahead of myself. So you're probably wondering, why do we have triangles? Well, so far in physics, we've only worked in how many directions?
Up and down. Up and down.
One. We've only been horizontal or vertical, right?
No.
Never together. Yes, Rex.
Shouldn't you start out at what is a triangle?
Now we'll get to that. That's geometry class. You can have that. Most of you know what triangles are, right? All right. So we've been working in all horizontal or all vertical, right? Right? Now we're going to take the horizontal and vertical and we're going to put them together. You're probably saying, why do we have to do that? Well, think about it this way. When you're playing basketball, if I want to make a basket, can I throw the ball completely horizontal and make a basket?
Yes. Yeah.
I can?
If you're tall enough.
If I'm tall enough, right? But there's no way, given that you're an average-sized human being, that you can throw the ball at an angle, velocity that is parallel to the ground and make a basket. Unless you're standing on something, right, Kevin? Okay.
World average
Okay.
to like 9 foot.
Is there any way that I can throw the ball completely vertically and make a basket?
Yeah.
If you're under.
Wind.
If I'm directly under, right?
Or wind.
We're assuming you're in a gym where there's no wind.
Fan.
There's no way I can throw unless I'm directly under the hoop, which I don't know if that counts or not. All right. If you throw a basketball directly vertical, you're not going to make a basket, right?
What if you hit the ceiling rafters and it bounced a couple times and it came down?
Well, then you're getting right to my point that I'm about to make here. Okay? In order to make a basket, the ball has to travel some distance horizontally and vertically, right? So when you shoot it, you have to shoot it at a angle, right? And the angle you shoot it at has some part that will go in the horizontal direction and some part that will go in the vertical direction. Right. Our next unit that we're working on I call it two-dimensional kinematics. The parts we're going to study in two-dimensional kinematics are projectile motion, which is like shooting basketballs, throwing baseballs, launching catapults, stuff like that. And centripetal force, which is objects traveling in a circular path, good. And Newton's law of universal gravitation. Because all that stuff is all working in 2 dimensions. Okay? So we need to, for our first step here, we need to learn how to take a vector, because in physics we're not so much worried about triangles as what they are in geometry. We're worried more about a vector. So let's say this is a vector of magnitude 15. Could be a velocity vector for shooting a basketball. Okay? So it's a velocity vector at an angle of 30 degrees. I want to find the x component and the y component. I want to find the part that's parallel to the ground and the part that's perpendicular to the ground. The horizontal and the vertical. Does that make sense? Which one's horizontal, x or y? X. Which one's vertical? Y. Now, in order to do this, we need to use this cool mathematical... Thank you, Kyle. I thought we were going to explode for a second. All right. We need to use this cool mathematical acronym called, anybody know?
Wait, what?
Pythagorean theorem.
Oh, no. Someone said it.
SOHCAHTOA.
SOHCAHTOA. So, SOHCAHTOA.
I know what that means.
You know what's the S stand for?
That means sine. And it's opposite in hypotenuse.
Opposite and hypotenuse.
That's close.
Cosine, adjacent, hypotenuse. Tangent.
Look, he can't spell Jason, so just put it.
Okay. So, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, this is something you probably might have familiarity with. Some of you probably have no idea what I'm talking about at this moment, but that's okay. We'll fix that here in a moment. All right. Now, others of you said something about a P word. What was that P word some of you used? Pythagorean theorem. Pythagorean theorem is?
3 sides. A squared plus B squared.
Okay. So that theorem may also be useful, and you can use that one if you like as well. I'll show you how you can use just sine, cosine, and tangent, or if you want to include Pythagorean theorem, you can use either one. All right. Where are we going to go next? Oh, Rex said we should start with a triangle, right? This is a triangle, 3 sides. This is a special type of triangle called a right triangle. In physics, we get to define our own way of looking at things, right? It's called a reference frame. We'll define our reference frame in every one of these problems so that the horizontal and the vertical are perpendicular, which means every triangle we'll work with is going to be a right triangle. Okay? We can make it a right triangle. Okay? We can break it up in the x, y components to make a right triangle. All right? This a squared plus b squared equals c squared. This only works for right triangles. Okay? Now, in a triangle, we have the legs, which are x and y, and we have the hypotenuse, which is 15. Right? The longest side is always your hypotenuse, and it's always across from the right angle. In this a squared plus b squared equals c squared, which one's the hypotenuse? C, right? A and b are the legs. So it'd be x squared plus y squared equals 15 squared. Now, a is not always x. A and b doesn't matter if it's x or y. Alright? Now that first triangle, we can't jump right into the Pythagorean theorem, which some of you might be more familiar with, so we need to use sine, cosine, or tangent. Which one do you guys want to find first, x or y?
We will find x, sir.
Okay, Rex said he wants to find x first. Okay? X is what to the 30-degree angle? Is it adjacent or opposite? Because we know it's not the hypotenuse. It's adjacent, because adjacent means next to, right? So if I want to find x, then I'm going to use sine. I know the sine of 30, which is my angle, equals the, not sine. Which one do I use?
Cosine.
Cosine. I was thinking about y, what Kevin has to do. All right. If I want to find x, I need to use cosine because x is adjacent and 15 is my hypotenuse. So cosine of 30 we know is going to be equal to x over 15. Okay. Does that make sense?
Yes.
A little bit.
So now how can I find x?
You multiply 15 to both sides.
Yeah, multiply both sides by 15.
You're a smart cookie.
So 15 times the cosine of 30 equals x. Now, should we be in degrees or radians in our calculator? Degrees. Okay? We will always work in degrees. Well, I shouldn't say we'll always. We'll most often work in degrees. Sometimes radians makes better sense than this, but usually it's degrees. So what is it?
I did that right, and I thought I did it wrong.
15 cosine 30. What is that? What is it? 12.9. I think you're in radians. Wait, no. Never mind. You're in degrees.
12.99. So we could call it 13 if you wanted to.
I'm in radians.
I know I'm right because that's what my
calculator
calculator is.
So I can go to degrees.
Hit mode. It's right next to second. And change. Go take the third one down, I think. So what was it again, Cassandra? 12.9 equals x. Okay. So this means that this is my basketball example. If I'm shooting a basketball with an initial velocity of 15 meters per second at a 30-degree angle, then it is traveling at 12.9 meters per second in the x direction.
Wow.
Okay. How can I find y?
It's
We can use Pythagorean theorem now.
Y is what to 30? Opposite. So I could use sine.
But it's really not necessary because you can use the Pythagorean theorem.
We could use Pythagorean theorem, but I think all of you are pretty well versed in the Pythagorean theorem. Okay. So I could use sine. I could go sine of 30 equals y over 15, right?
Yep.
Or we could use tangent because I know x now.
You could.
Okay. I could also use tangent of 30. Now equals opposite y over adjacent x. Okay. Oh, Rocket 30 day.
Yep.
All right.
Man, I would have to be saying the same thing.
So while you're leaving, I'll solve it still. How do I solve multiply both sides by? By what? 15. So that means that y equals 15 sine 30, which equals 7.5.
I could have told you that.
Okay. So that's how we can find our two components.
Didn't have to go.